Alright, in this video I'm going to talk about counting with repetition, or you can think about it as being counting with replacement. So something that happens the first time can, in a sense, happen the next time. That's the idea. So the basic idea we're going to use is what's called the multiplication principle, and this is just a very fundamental idea when it comes to counting the number of ways that something can happen. Basically says, suppose you have a bunch of things that can happen. Usually they call these events, so E1, E2, E3 up to E sub n, some generic number of events. They call them independent events. What that means is if one event does or does not happen, that has no bearing on the fact of whether another event does or does not happen. So that's the notion of independent events, and I'll talk about this a little more in depth in some other videos. Okay, it says basically if each event can happen in a certain number of ways, suppose E1 can happen in M1 ways, E2 can happen in M2 ways, E3 can happen in M3 ways, etc. It says if you multiply the number of ways that each event can happen, that's going to be the total number of ways for all n events to occur. Okay, so that sounds a little more confusing than what it is. So let's do a couple examples here to maybe make some sense out of it. So in my first example here, it says how many combinations can be made for a briefcase that has a 3-dial lock with each dial having numbers 0 through 9 available. So I'm sure you've seen these locks. You've got some businessman or a woman got their confidentials all locked up. So on their little briefcase, you see a little 3-dial lock. And maybe there's a combination of 1, 2, 7 that opens their briefcase, or maybe it's 3, 8, 0, maybe that opens up their briefcase, or maybe they're really clever and they make it 0, 0, 0. Okay, so the idea is how many different possible lock combinations could you have? So maybe you're not quite so trustworthy, and maybe you're a thief and you want to know, would I have to check, maybe 10 combinations? Because that way, maybe it wouldn't really take that long to actually get into their briefcase. If it takes a million combinations, if there's a million different possibilities, that's probably not going to be worth your time. Well, the idea is you can think about the first event as picking a number. So the number of ways to pick the first number, well, if there are numbers available between 0 and 9, so you have to pick a number for the first dial. Okay. The second event you would have to do would be pick a number for dial 2. And then the last event you would have to do would be to pick a number for dial 3. Those are your separate events, picking numbers. Well, how many different ways are there to pick a number for dial 1? If there are digits available 0 through 9, well, that means there's 10 choices for the first number. Since we can repeat numbers, there's 10 choices for the second number. And if you can, again, repeat numbers, there would be 10 choices for the third value. If you multiply those together, that's 10 times 10 times 10. Hey, that's 1,000 different possible lock combinations you can have. And intuitively, if you think about it, that makes sense. You could have anything from 0, 0, 0, that could be your smallest, 0, 0, 1, 0, 0, 2, if we were to actually list all these out, until eventually you would get down to 9, 9, 8, 9, 9, 9, and you can count all of these. You'll have 1,000 different possible lock combinations. So that's the basic idea. You're just kind of multiplying things together here. Suppose you're in the big house, jail. Maybe that's the small house. I don't know. I haven't been to jail yet. and you're making license plates, and maybe you're free to go after you're done making license plates, and you want to know, well, geez, how many license plates am I going to have to make before I get out of here? And suppose we make the following restriction, and if you look at license plates on cars, at least around here at the time of me saying this, you typically have license plates, well, things are changing, but at least at one point in time there were 6 entries, and the first 3 entries had to be letters, A, B, A, followed by numbers, 2, 1, 8. So this is the idea. If the first 3 entries can be letters, and then the last 3 entries have to be numbers, how many different license plates can you make? Because, right, you want to be able to uniquely identify a car. Well, again, we're going to use the multiplication principle. The number of choices for the first entry, well, it's the number of letters, and at least in the English alphabet, there are 26 choices for a letter. Well, you can have repetition. So for the second choice, again, you've got a choice of 26 letters you can use. For the third entry, again, we're picking letters. Well, we have 26 entries that we can have. And now we're picking numbers. So for my fourth entry, it's got to be a number. Well, it's got to be between 0 and 9. So I've got 10 choices for that one. For my fifth choice, again, I have to pick a number. I've got 10 choices. For my last number, I again have 10 choices. So it says you get 26 times 26 times 26 times 10 times 10 times 10. If you multiply this out, it turns out that you're going to have to make 17,576,000, and that's it. License plates. So those are the total number of license plates that you can make, different license plates that you can make. If the first 3 entries have to be numbers, the last 3 entries have to be, I said it backwards. If the first 3 entries have to be letters, the last 3 entries have to be numbers. Okay, suppose for our last example here, suppose you're going to take a multiple choice exam. It's got 10 questions, and each question has 5 different answers available. And you want to know how many different ways that exam could be answered. Okay, so maybe in your head you're thinking, if I randomly guess, what is the probability I would somehow ace the test? Okay, so counting and probability definitely goes hand in hand, and I'll talk about probability in some other videos. So you've got question 1, 2, 3, on down the road, 9, 10. Well, how many choices are there for question 1? Well, it turns out there's 5 choices for question 1. There's 5 choices. You could think about your events as being guessing an answer for question 1. Event 2 would be guessing an answer for question 2. You have 5 choices for the next one. All the way down the line. You have 5 choices for each one. So that means the total number of ways you would have would be 5 for the first one, 5 for the second one, 5 for the third, etc. Whoops. 5, 6, 7, 8, 9, 10. You have 5 choices for each one. So it turns out there's 5 to the 10th different number of ways to produce a solution key for that exam. 5 to the 10th is a pretty big number. It actually turns out that there is 9,765,625 different ways to answer that multiple choice question of only 10 questions that has 5 different possible solutions for each question. Okay, so you can see here, even without a large number of questions and a large number of possible solutions, there's a whole bunch of different ways in which you could produce a solution key to that test. Okay, so this basic counting idea, this multiplication principle, is something that's very fundamental. Again, it's something that's important, and again, the idea is here that's important also is we're sampling with replacement. whatever I choose one time, I'm allowed to choose it again. You know, maybe I pick A the first time, I could pick A the second time, A the third time, all the way down the line. If you cannot pick the same thing over and over, the counting techniques are going to be a little different. That's when you start using combinations and permutations. So I'll talk about that in some other videos as well.